Many consider Steinmetz to be the father of alternating current systems. He received 29 patents for various inventions related to AC circuits and electric power systems. The scope of his work was truly impressive. But how did he come up with these inventions? What made him so inventive? His approach can be summarized in three: experimentation, analysis, and generalization. He would first build a physical model to conduct experiments. Then he would analyze the results and formulate a general law that could be applied in other situations. Let's look at some of his more interesting inventions and how they came about. In 1886, Steinmetz invented the single-phase induction motor. He built a small model consisting of a laminated iron core with a few turns of wire and placed it between the poles of a strong horseshoe magnet. He then connected an AC voltage source to the coil. When the current changed direction as the iron core, it caused the magnet to rotate. The speed of rotation depended on the frequency of the AC source. Steinmetz connected an induction motor to a variable frequency drive and was able to control the speed of a fan, an invention that was considered miraculous at the time. With this invention, Steinmetz solved two major problems with AC circuits. First, how to start an AC motor, and second, how to control its speed. Let's take a closer look at how he did it. First, the iron core is made from thin sheets or laminations of iron. This reduces the eddy currents inside the core and improves efficiency. The coil has a few turns because at low frequencies, a large number of turns would make the motor too large and expensive. To start the motor, he used a capacitor to shift the phase of the current by 90 degrees. This creates a leading current that produces a rotating magnetic field. The motor starts rotating in one direction. To reverse the direction, he switches the phase sequence of the input voltage. At that time, no one had ever built an induction motor larger than a few horsepower. Steinmetz designed the world's first practical and efficient three-phase induction motor, laying the foundation for the widespread use of AC power. Steinmetz was also one of the first to recognize that skin effect could be a problem at high frequencies. As frequency increases, the effective diameter of a wire decreases, which increases resistance. Skin effect makes the current flow on the outer surface of a conductor. At low frequencies, the current is distributed over the entire cross-section of a wire. As frequency increases, the path length of the current increases while the effective cross-sectional area decreases. Both effects increase resistance. Steinmetz found that at 60 Hz, the effective diameter of a copper conductor was reduced by 25%, and at 15.0 Hz, it was reduced by 75%. This led to the first skin effect studies and inventions such as double and triple conductors, where multiple parallel wires are used to reduce the effect. Steinmetz was also the first to discover the rotating magnetic field concept, which is crucial to the invention of the induction motor. Interestingly enough, Nikola Tesla independently discovered the same principle a year earlier, but Steinmetz was the first to publish it. Tesla claimed that he invented the induction motor. While he did invent the induction coil, the induction motor was not commercially viable until Steinmetz improved upon his design. So who really invented the induction motor? Perhaps both of them. Science and engineering progress through the work of many people building on each other's ideas. Another important contribution of Steinmetz was the invention of the wattmeter. Before his invention, there was no practical way to measure AC power. Steinmetz's wattmeter could measure both active and reactive power, something that was impossible with the wattmeters used at the time. His wattmeter was based on the principle of using two wattmeters to measure a three-phase circuit. One wattmeter measures the real power, and the other measures the reactive power. By adding the readings of both meters, you get the apparent power. This invention allowed engineers to optimize the efficiency of AC circuits by minimizing the reactive power, which reduces the size and cost of the conductors. Many of Steinmetz's inventions were lost due to the Great Fire of 1906 in San Francisco. He lost his home, his office, and all his research notes and data. But he continued to invent and teach until his death in 1923. His students and colleagues kept his memory alive and continued his work. Steinmetz left a lasting impact on the field of electrical engineering, and his contributions continue to shape the world we live in today. Did you find this video useful? Let me know in the comments. Check out my other videos and subscribe for more.